Hello, Geometry crew. In day 6 of our SAT unit, what we're going to go over is SAT style problems that fit into our trigonometry chapter that we did previously in the year. So we're going to go over specific trigonometry problems that we know how to do in our sophomore year after this chapter. So if we take a look at some of these SAT problems, one thing that we're going to see is that a lot of these questions are going to be rather lengthy, okay, maybe very confusing in terms of the way that they're written. So we're going to get through this and we're going to go over 7 questions on trigonometry from the SAT. So let's get started on the first one. It says in the figure at left, JLK and JNM are both right triangles. Which of the following is equal to KL? It's really important to note that some important things to look at is obviously what the question is asking, how the answers are presented, and then of course what the diagram can tell us. All right, so we're going to go through some of these things. All right, so what the question is asking is what is equal to KL? So basically it's just figuring out what is KL equal. Now KL in the diagram is this segment in that smaller triangle. If we notice from the diagram though, we're given this angle in the big triangle. From the diagram, both of these triangles are right triangles. We can see that, and one thing that we should be able to see is that these two triangles are similar. Remember, similarity means that all the angles in the triangles are congruent. So these two triangles are proportional. All right, so that means if this angle is y, that means this angle, its corresponding part, is also y. So those corresponding angles are congruent. All right, so now we've got a little bit more information about that smaller triangle that it's asking about. In order to find that segment length, we have to involve KL, and of course we have to involve y. Taking a look at the answers, we can see y is in every single one of these answers, and we can see sine, cosine, and tangent listed in the answers to the right. So we have to use one of these trigonometric functions. If we remember from day 5 or from our trigonometry chapter, in terms of those trigonometric functions, we could use Sohcahtoa. So remember, so means sine is opposite over hypotenuse, ca means cosine is adjacent over hypotenuse, and toa means tangent is opposite over adjacent. Of course, we got to figure out which one can we use. Okay, it's asking for KL, which is the adjacent side with respect to angle y. All right, now we also have to figure out, okay, what's the other side that we have to use to set up this trigonometric ratio or this trigonometric function? In terms of that question, we could take a look at the answers. If we take a look at the answers, one thing that we're going to notice in every single one of these answers is JL is in every single one of those answers. So it's suggesting that we use JL and of course KL when constructing this trigonometric function. All right, JL is the side opposite of y, and then KL, like we said before, is the side that's adjacent to y. So that means O and A, which refers to tangent. So we're going to use tangent here. All right, so tangent of y is opposite over adjacent, which would be JL over KL. Now, of course, the question is asking, let's find KL. So we have to solve for KL in this example. If we remember this algebraic trick to solve for KL when it's in the denominator here, we're just going to switch those two things. All right, so that means KL equals JL over tangent of y. And remember, the reason why is because when we take those steps to solve algebraically here for KL, we would multiply by KL on both sides, and then from there we would divide by tangent of y, and we'd get JL over tangent of y. All right, and that results in D being our answer, JL over tangent of y. All right, so for that first one, not too difficult to solve. We just have to make sure to remember how to set up those trigonometric ratios and then what similar triangles are. All right, so now from there, let's go to example 2. All right, you'll notice in this example, it's very wordy. That's another similar thing that we're going to see in a lot of SAT style questions, is that they're very wordy. And then also, not all of the information that's given in these problems do we actually need. So that's why I said before, let's focus on what the question's asking, and let's focus on the diagram and figure out how we could get to the possible solution. So I'm going to read this one that says, the figure at left has a vertical line of symmetry in the middle. Half the length of the base is 4 feet. Angle BOA is 30 degrees, and the line segment BA is 6 inches in length. Given that the square root of 3 is approximately 1.73, how tall is the figure in inches to the nearest inch? All right, so what are we looking for? Okay, we are looking for the height of this triangle, which is that segment there. All right, and of course, we're given that this segment is 4 feet from the diagram. One thing to note is that the question asks, how tall is the figure in inches? So maybe it would be a good idea to convert this 4 feet into inches. All right, so we could multiply 4 feet times 12, okay, 12 inches per foot, and we would get 48 inches, okay, for that segment below. Now this still doesn't get us all the way there, so we have to use some of the information given from the diagram. So one of the first pieces of information that's given from the diagram is that, or sorry, from the question is that BOA is 30 degrees. So that is that angle right there. That, we're being told, is 30 degrees. All right, so we have 2 out of these 3 angles in that small triangle there. So that means we could find this third angle. So that third angle is 60 degrees. Now the reason why that's useful is that this third angle is used to construct both of these triangles on the right side. All right, it's used to construct this medium-sized triangle, and then of course the big-sized triangle that has the 48 inches in it. So obviously that's really important. So if we remember our special right triangle ratios in a 30, 60, 90 degree right triangle, the ratios are 1, root 3, and 2. Okay, so the side opposite the 60 degree angle, which is that 48 inches, has a ratio of root 3. And this side, the side that we're looking for, is the short leg of that 30, 60, 90 degree triangle. So once again, if we remember day 5, what we talked about yesterday, we could find this side length by just dividing by that ratio. All right, so if we take this length that we have, 48 inches, and divide by root 3, we're going to get that side that we're looking for. Now in the question it says the square root of 3 is approximately 1.73. It's suggesting that we use that 1.73. Now we can, or we don't really have to. We could just type in the square root of 3. But if we do that, we have 48 over 1.73. And if my memory serves me correctly, we get about 27. Is that right? 27.7 inches. And of course, the question asks us to round this to the nearest inch. So that would be 28 inches for this example. So in this question, we can skip through some of the information that's given, use the diagram, and of course use our knowledge on 30, 60, 90 degree right triangles to find the answer. All right, let's move on to example 3. So I'm going to clear the board and move down here. All right, so now in example 3, it says, what is the measure in degrees of angle BAC in the figure shown at left? This one's rather straightforward. It's asking us what this angle is, angle BAC. So I'm just going to put theta there. That's the angle that we're looking for. And it's giving us these 2 legs of this triangle. All right, from the last question, if we remember those ratios of a 30, 60, 90 degree right triangle, we might see that, hey, actually, this is a 30, 60, 90 degree right triangle. All right, this is AC corresponds to the side length across the 30 degree angle. BC corresponds to the side length across the 60 degree angle. It has those ratios 1, root 3, and then 2. All right, so since this angle that we're looking for is across from that side length as the root 3 ratio, That means that angle has got to be 60 degrees. All right, pretty straightforward there. All right, another way that we could do this, and of course there's plenty of different ways we could do these questions, is of course we could set up an inverse trigonometric function to solve for theta in this example. One thing that you're gonna notice is that when I post the explanations for the notes, those are the explanations, or those are the answers that is coming from the SAT. So you're going to notice that those explanations might be a little bit different than the explanations that I provide. What I'm explaining is just how I'm working through the problems. Okay, so you can take a look at this video, and then you could also take a look at the notes answers that I post and see, you know, which one of those you like a little bit better. All right, so now let's move on to example 4. Okay, once again, we got another wordy question here. There's a lot of information here. And once again, not all of it is necessary. Okay, if we just look at the diagram alone, and then we just look at the question that's asked, this question asks, which of the following is closest to the length of AB? So once again, the question is just asking us, what is AB equal to? If we look at AB in the diagram, that's in the top right triangle. Okay, that's this, what appears to be that shorter leg there. Okay, and if we take a look at the bottom triangle, we're given some information as well, the longer leg there. Okay, this is just a rectangle, and AC is the diagonal. So that diagonal divides this rectangle into two congruent parts. So what that means is these two triangles are congruent. So that means their corresponding parts are congruent. Okay, so that also means that BC is 7. Okay, so we have 7 right here, and what we're looking for is AB. Okay, if we take a look at the at some of the information given here, it says DAC is 27 degrees. That is this angle right there. So its corresponding part would be angle ACB. Right, so that's 27 degrees. So it's clearly saying we need to use this 27-degree angle and then use that to help us find the length of AB. So we're going to use this angle, and of course we already have that side length, and we're looking for this missing side. So this actually is a rather straightforward trigonometric problem, trig ratio problem here. All right, with respect to that 27-degree angle, x would be the opposite side. 7 would be the adjacent side, and opposite over adjacent refers to tangent. So tangent of 27 degrees equals x on 7. And it tells us, hey, let's use 0.51 for tangent of 27 degrees. All right, so that's 0.51 equals x on 7. And then from there, we just have to multiply by 7 on both sides. So if we do 0.51 times 7, we get 3.57. So that would be B. All right, let's take a look at the next one. So I'm going to clear the board to move on. So in example 5, this one's rather interesting. Which expression is equivalent to cosine of 35 degrees in the right triangle shown to the left? So in Algebra 2, we're going to learn some theorems that'll really help, really easily help us solve this problem. But we don't know some of those theorems right now in geometry. Okay, so we're going to just use what we know to help us solve this problem here. So cosine of the 35-degree angle. I'm just going to mark what side length is talking about there. All right, so cosine is adjacent over hypotenuse. So that would be this side, xz, divided by this side, zy. All right, so we're using those two side lengths to construct that ratio. It's just saying what trigonometric ratio is equivalent to that. So it wants us to use this angle, of course, because we're already using z there. Okay, so with respect to angle y, what trigonometric ratio would be using those side lengths? So opposite of y would be xc, And of course, the hypotenuse is zy. So opposite over hypotenuse would be sine. So sine of y is the same thing as cosine of z. So that, of course, leads us to B as the solution, and that also leads us to some of the theorems that we'll talk about when we get to Algebra 2. All right, this next example actually isn't from our trigonometry chapter, but I thought it was kind of interesting and useful, so I wanted to talk about it. This says, what is the radius of a circle whose circumference is pi? Okay, the circumference is one of the formulas that were given from the SAT. And it says the circumference is pi, so instead of circumference, I'm going to write pi. And it's just asking us, what does the radius equal? So just solve for r. So we got to get rid of that 2 pi, so we're going to divide that whole quantity by 2 pi. And notice we have pi over pi here, so that cancels out. Pi divided by pi is just 1. So that leaves us with a radius of 1/2. All right, nice and quick little divergence from our trigonometry there. All right, and then we get to the last one here. All right, so in example 7, it says tangent of r is 5 on 12. What is the side length of PR? All right, as we know, tangent of the angle is just the ratio between the opposite and the adjacent sides. All right, so if it says tangent of r is 5 on 12, it's saying that the opposite side with respect to r is 5, and the hypotenuse is 12. Okay, so, sorry, not hypotenuse, my bad. The adjacent side, which makes a little bit more sense, is 12. All right, so with respect to angle r, we can see that that adjacent side is 12. All right, and the opposite side is 5, so we can just mark it down as 5, so that's PQ. And then we could use this to find PR. This is just Pythagorean theorem right here. We have 2 sides out of 3 in a right triangle, so we can construct Pythagorean theorem. So I'm going to write it as c squared equals a squared plus b squared, where a and b are just those 2 legs, and c is what we're looking for here. Okay, so I'm going to substitute 5 in for a, 12 in for b, and let's solve this thing. All right, so for in this example, 5 squared is 25, 12 squared is 144. And if we add these 2 together, we get 169. And if we take the square root, we get 13. So B again in this example. All right, folks, so that's it. If you have any questions on that, especially if you have any questions on the homework that I assigned today, make sure to email me and ask. All right, thank you and have a good day.